Welcome to the channel. Decode the complex. Master your code.
Hello everyone, this is Deepak Kumar and today we are going to discuss question number 1015. The question name is smallest integer divisible by k. So basically in this question we are given a positive integer k and we have to find the length of smallest positive integer which is n length n digit of length and only contains 1 as its digit. And now if there is no such number then we will have to return -1. And now there is a note that the integer n may not be fixed in a 64-bit signed integer. This means the length of n can exceed 19 digits. So let me tell you about my approach and what we are going to do here. Now value of k, let's say we are given is 7. So let's try one by one. Is 1 divisible by 7? Absolutely not, as we will be having a remainder of 1. If the number is 11, then will it be divisible? Then absolutely not. It will still leave the remainder of 4. What if triple 1? Then still will leave a remainder of 6. What if it's 4 times of 1? Then it will again leave some remainder. But if we carry on to digit 6, then it will certainly be divisible by 7, giving us the remainder 0. So now we can keep this loop forever. But the thing is, the number can exceed the 2 to the power 64 digits. So what we are going to do is to take the remainder of last one and then multiply it by 10 plus 1. Let me give you an example. Like if I am talking about 11, then what I will do is to find and divide it by 7. Then what I will do here is to calculate its modulus or its remainder, which will be 4. Then what I will do is to multiply it by 10, then add 1, which means it will become 41. Now, as you can see, in triple 1 or 111, 70 was already divisible. So, leaving only 41. And we will repeat this process so that our number does not get too bulky. And we can use it while being inside our limit. And now, second thing. If I say my number consists of only 1, then can 1 divide the number? Absolutely. Can 3 divide the number? Surely yes. For example, triple 1. Can 5 divide a number? No. Because when a number is divisible by 5, it will either end by 0 or by 5, but not by 1. What about 7? I have already shown an example of 6 times of 1, which is divisible by 7. What about 9? Then when a number consists of 9 ones, then it will surely be divisible by 1, 9. So now, what about even numbers? Can any even number divide the digits containing only 1? So no, it won't be possible, because if a number is even, uh, then no matter what we multiply to it, it will always be a even number. Like if I am going to multiply 2 by a odd number, which is 3, then here I will be having 6, and we can try it on any of the even numbers. It will always be an even, never an odd, and the number ending with 1 is always an odd. So we will have to check for only 1, 3, 7, and 9. So now let's move back to the code and I will show you what my code will be. So here we are. Let's start our code. We will be checking if my code is even or it is divisible by 5. Then we will return just -1 because I have already shown you that any number which contains 2 or 5 cannot divide a number containing 1 as its or a one's digit. Now let's declare a variable integer of remainder. Now we will start our for loop. I am going to start with 1 and I will keep it to k because at k equals 7, the number which was divisible was 6 digits long. So there might be any case. So we will keep that in mind. Now what I will do is to calculate remainder. Now you can see what I have done here. I have calculated the remainder as always. Like I told you in the previous one, where I had divided 11 by 7, where I got the remainder 4. Then I had multiplied it by 10, then added 1 for the next step, where it became 41, where 70 was being subtracted as a part. Now I will check here if my remainder became 0. As if it became 0 anywhere, we will return I because I will be the length of the number which will be divisible. Let me show you my example here. Let's say the k value of k is 3. So at I equals 1, remainder will be 1. At I equals to 2, my remainder will be 2 again. But when it then I will multiply it by 2, remainder by 10, then we'll add 1, which will become 21, leaving no remainder. Now, as the loop has been gone through 3 times, which means the number which shall be here is 111, which is surely divisible by 3. Now you can verify it by the rule of divisibility by 3, where the sum of its if it is divisible by 3, then number shall be divisible by 3. And here 1 plus 1 plus 1 is 3. So it will be divisible by 3. Now moving on back to the our code. Now here we will return -1. Let's say if all the what I am doing here returning -1 because if the loop went while but there was no integer to be found which was divisible by the number k, which was divisible by the number k, we will return -1. Now let's try some test cases. As you can see, the test cases given in the LeetCode have been cleared. So let's add some of our own. Here I will add 50, which contains 5. We will add 30, which contains both 2 and 5. Now we will add 7 and then 11. And for the last one, 13, a prime number. Now let's try these test cases. As you can see, all the test cases have been cleared. See here, at 15, it returns a -1 and it was expected. At 30, again it was -1 which was expected value. But after that, at 7, output was 6, which was expected. At 11, it was 2, which was 11 itself. And at 13, it was again output 6, which was 111. So now let's submit the code. So you can see all the test cases given here in the LeetCode has been cleared with the 100% beat. And as our complexity is just O(n) with no space complexity or constant space complexity of O(1), So this is all for today. Hope you liked the video. Please like our video, subscribe the channel, and comment down your thoughts. The solution link will be in the comment section. Thank you.